This is Pre-Algebra, Section 10-5, Multiplying Monomials. My name is Mr. Rupp, and in this video I will show you how to multiply, divide, and simplify rational numbers using exponent rules. You'll learn how to interpret positive whole number powers as repeated multiplication, simplify and evaluate expressions, and how to multiply monomials. By the end of the video, you should be able to add, subtract, multiply, and divide monomials and polynomials, and solve multi-step problems using these techniques. Let's get started. This section is titled Multiplying Monomials. And a good question to ask would be, what exactly is a monomial? Okay? Well, let's get some definitions down. A monomial is a number, a variable, or a product of one or more variables. The next thing we need to know is, what's a polynomial? So let's get a definition for that. A polynomial is a monomial or a sum of monomials. So now we have a couple of keywords here that we need to pay attention to. Remember what a product is, right? A product is what happens when you multiply two or more things together, such as x times y. That is a product. A sum is when you add, all right, such as x plus y, or x plus negative y, because addition and subtraction is just addition with a negative sign. So where is this leading us to? We're going to talk about exponents for a minute. Now, we have a couple more vocabulary terms that we want to talk about regarding exponents. We have the base, okay, which is this blue 2 right here, blue 2, yeah. Then we have an exponent, which is this red 4, okay. Now the exponent tells you how many times you multiply the base together. So if you look over here, these 4 2's that we have lined up, those are called factors. So we have 2 times 2 times 2 times 2. There's 4 of them. So in exponent terms, that's 2 raised to the 4th power, because you're multiplying 2 4 times. We're going to go backwards now, because we need to figure out what to do when we multiply two terms together that both have exponents in them. All right, so what if we had something like this? 3 squared, and we multiplied it by 3 to the 4th. Well, now what we're going to do is we're going to take exponents and we're going to lay them out as repeated multiplication. So here, 3 squared is going to turn out to be 3 times 3, right? Times, now 3 to the 4th is 3 times 3 times 3 times 3, because the 4 tells you how many times you multiply the 3 together. 1, 2, 3, 4. Okay? Well, now this equals 3. How many 3's are here now? 1, 2, 3, 4, 5, 6. So we have 3 to the 2 plus 4, which is equal to 3 to the 6th. Down here we have 6 factors, and these 6 factors come from this 2 and that 4. Alright, so that leads us to a key concept. Yay, key concepts. This one's important, okay? This one's called the product of powers. And the product of powers simply says to multiply powers with the same base. Powers with the same base, add their exponents. as you have already seen. Okay, so for example, if you had 2 to the 4th times 2 cubed, that would be 2 to the 4 plus 3, or 2 to the 7th. So in general then, if you have a to the x times a to the y, then this becomes a to the x plus y power. Alright? You have to remember that this only works if the bases are the same. And remember from up here, the base is the number that the exponent is acting on. Let's do a couple of examples. This will be example 1 on page 545. All right, and this is an example of multiply powers. So it says, if find 5 squared times 5. Find that product, and it says express using exponents. Okay, so 5 squared times 5. You have to remember something here. 5 squared times 5. 5 is raised to an exponent. You just don't see it because we don't write it. The exponent, that exponent is 1. Anything raised to the first power is itself. Okay, so 5 squared times 5 to the first. So this equals 5 to the 2 plus 1, or 5 to the third power. Let's do another example. Let's do example 2 on page 546. This says to find this guy, negative 3 x squared times the quantity 4x to the 5th. Alright, panic sets in. No, this is easy. Okay, we take these apart a little bit at a time, and I will show you how. This, you move things around that are like terms. Okay, so the negative 3 and the 4 can be moved together. Negative 3 times 4. Multiplication allows you to do this, remember? Yes. Negative 3 times 4, and then what's left is x squared times x to the 5th. Well, that doesn't look so terrifying now, right? Because negative 3 times 4 is what? Negative 12. And x squared times x to the 5th, well, we've learned that already now, right? That's x to the 2 plus 5, or we have negative 12 x to the 7th. Okay? Not so big of a deal. There we go. Okay, we're going to do another example, example 3. And I put the problem text up here because it's difficult to follow along in a word problem without having the words of the problem. You get lost in it. So here it says the population of Groveton is 6 to the 5th power. The population of Putnam is 6 to the 3rd power times as great. How many people are in Putnam? Okay, now this is about English. So when you see something that says times as great right here, that means that you need to do something. So the population of Putnam then, okay, population of Putnam is, what's that mean? That means equals. Okay, 6 to the 3rd power, 6 to the 3rd power times as great as the population of Groveton. Okay, there it is in basically words, math words. So what's that look like? Okay, well, then the population of Putnam is equal to 6 to the 3rd times, well, what's Groveton? 6 to the 5th. And that's equal to 6 to the 3 plus 5, which is equal to 6 to the 8th. Okay? Again, not so terrifying. Remember that in all of these examples we've done so far, the base has been the same, which has allowed us to do this kind of math. All right, if the base is not the same, this does not apply. You have different rules that you need to follow, and you learn that later. Now, from way back when the dinosaurs ruled the earth, T-Rex was stomping around the swamps, chasing us poor humans, and we sat around the campfire and we discussed negative exponents. We are getting back into that now again. How do we multiply using negative powers? Negative exponents. Here is what we learned from way back in section 2-9. Zero and negative exponents. And I'm not going to write this out, you can copy it down. It says any non-zero number to the 0 power is 1. All right, so over here, let's do that. Any non-zero number, let's say 8, to the 0 power is 1. Any number you want to name, negative 100 to the 0 power, 1. Non-zero. Now, what we really need to learn about is any non-zero number to the negative n power is the multiplicative inverse of its nth power. Okay, now that's a good example of mathematicians making something difficult that really doesn't need to be that way, okay? Here, for example, all right, let's say we have 5 to the negative 2 power. All right, well, what does that mean? That means this. That means that it's 1 over 5 to the positive 2 power. That's all that means. Anything raised to the negative power is that anything in the denominator raised to that positive power. And what this means is 1 over 5 times 1 over 5. Now you can go the other way, okay? If you had 1 over 3 times 1 over 3 times 1 over 3, this would be 1 over 3 raised to the 3rd power, or, which would be 3 to the negative 3, because when you bring this upstairs now, when you take it out from the fraction, then you add the negative sign to the exponent. All right? So this is what we learned back in 2-9. I don't want to, go back over this too much. What we're going to do now is we're going to use it. And we're going to use it in example 4. And this is called multiply negative powers. All right, now we're going to do this in 2 methods. All right, and I'm going to do method 2 first. So in method 2 is going to use the negative exponent rules, or exponent rule, from section 2-9. And so what that says is this. Well, I guess I should put the example 4 problem up. We have this guy, x to the 4th times x to the negative 2. All right? Oh boy. Well, we're going to use method 2 first. Method 2 is what we just went over explaining right here about the negative exponents. All right? So method 2 says that x to the 4th is x times x times x times x 4 times, and then you multiply it by 1 over x times 1 over x. Okay? Well, what does that equal? Well, you got 4 x's. 1, 2, 3, 4, all over 2 x's downstairs. Well, you can see what's going to happen here, right? This x and this x cancel. This x and this x cancel. And what are you left with? You're left with x to the 1, 2. X squared. All right? That's the answer using exponent rules, what we just talked about. Here is method 1. which is what we are going over in this section now, multiplying monomials. So this is going to use the product of powers, all right, that we just learned. The product of powers. And the product of powers says that if you have x to the fourth times x to the negative 2, what this really means is that you have x to the 4 plus negative 2. All right, which is x to the, what's 4 plus negative 2? 2. There you go. Product of powers is a lot faster and a lot more clear than mucking around with a whole bunch of exponent factors and getting them all to line up and cancel and all that rot. Okay, that's a great way to learn from the beginning, but now that you have a much more elegant way of solving these, I suggest you use it. Okay, thank you for watching, and I appreciate your time. Like the video if you would. If you don't, you're not going to hurt my feelings again. Please let me know somehow that you've watched the video, because I find it useful to determine how many people are watching it. Anyway, thank you, and I will see you next time.